Hey everyone, welcome back to Web Inspector. Today we're going to do something a little bit different. Today we're going to play with a tool called Pico 8. And we might actually do things like this a good amount in the future because Pico 8 I feel like is a really good way of learning some of the basics of how game programming works, learning some good solid foundational things for not only game development but also web like animations and things like that. It's just really good for you to get a feel for how this sort of programming is done. And Pico 8 makes this really low barrier to entry. So Pico 8, as you can see here, is a fantasy console for making, sharing, and playing tiny games and other computer programs. It gives you a very limited number of things you can do with it. Everything you kind of have to build from scratch. It doesn't have a physics engine. It doesn't have any of the amenities that you find in a lot of game development platforms these days. So it really makes you start from scratch and learn things the hard way, which as a programmer, I feel like that's a very good way to level up in a very simple way, is to learn how things are done at the root level. So we're going to dig in today. We're going to do a little bit of Pico 8 stuff, and I have an idea. I want to build a basic game of life with Pico 8. So Conway's Game of Life, if you haven't heard of it, it's a cellular automaton devised by a mathematician, and it's very simple. It's a very simple set of rules that, when applied to a map full of dots like this, they create interesting patterns. Basically, that's all it is, and it's just a mathematical formula. But it takes a little bit more to actually set that up in a game development context. So this is going to teach us some of the basic principles of Pico 8, and it's also going to be a nice little challenge for me. I'm going to try to build this entirely on screen with you guys watching. I'm going to try to cut as little of it as possible. I'll only cut it if I'm unable to keep up interesting commentary. But hopefully this will take half an hour, 45 minutes, and we should be able to build the thing from scratch and see it run through Pico 8. So I'm going to put this over here. I've got the Game of Life. I'm going to have the manual for Pico 8 up in case I need it. And let's get started. So this here's Pico 8. It starts you out with a command line type thing. If you press escape, then it takes you to the editor. This is the code editor right here. So just to basically show you a little bit about how this works, Pico gives you an API to use. It gives you some very simple functions that you can use to build everything. So you have like rect fill, and it uses an X and a Y, and then an ending X and a Y. So if we do this, and then you also have to give it a color. So if we run that, you can see it adds that box to the upper left part of the screen. So there's our box. That's just a very small example, and you're going to learn a lot more about Pico 8 as we go through this. So Pico 8 has some basic functions that we'll want to use from the start. It has an init function that you can use to set up variables and stuff. It has a draw function. All of the internal functions start with underscores. So draw, and then it has an update function. I'm going to put the update function in between, actually. Function update. And we're going to use all of these for different purposes, for different things. So one of the first things we need to do if we're building a cellular automata is we have to create the actual cells. And to create the cells, we have to create essentially we have to create the data set. And the data set is going to be a two-dimensional array. So you've got columns and you've got rows. So you essentially want to set up data that will let you simulate those columns and rows. So we're going to do that first. We're going to set up a function called make map, and it's going to take columns and it's going to take rows. And to do this, we want to first create we're going to use a couple loops. That's what we're going to do. So we'll set up a local variable called new map, and set it to an object. Lua, or the subset of Lua that Pico 8 uses, doesn't actually have arrays per se, not like JavaScript does. It only has objects, and objects can be used as objects or arrays. It's actually pretty similar to JavaScript in a lot of ways. So then we want a loop. All objects are 1-based, not 0-based, which is a little bit strange. Then we're going to go to the end of columns, and then we're going to have another loop, 1, and we're going to go to the end of rows. And then new map. Let's see. So new map, so actually we have to set up variables here. X equals 1, y equals 1, new map x, y, and then we're going to set that to a random number. Well, we're going to floor the random number. So we're generating a number, random number. It's going to be either 0 or 1. It's a random number between 0 and 2, and then we're just rounding it down. We're going to set that random number for each cell in this grid that we're creating. And then with the new map, we're going to return the new map. One thing I'm missing here that I notice right away is x doesn't actually exist yet. So we have to create that in the first loop. We have to do new map x equals object. Then we loop through the rows. We create all of those. That should work. That should work. All right. So we've got this map. I'm going to copy this loop. We're going to use these loops a lot, where we loop through the whole data set. So I'm going to copy that down into our draw. Now, I feel like we have the right data set up. Let me remove that. Let me see if there are any errors first. No errors. So I feel like we have the right data set. We need to verify that first. So we're going to need a few things. We want to draw this to the screen, and we'll use these same loops for this. I don't think we need that, though. So we need a map. So I'm going to create a map. Let's say grid equals that. And then I want to set the columns to, we'll set it to 16, rows equals 16. We'll do that first. And then I also want to have a multiplier for how big the cells in the grid should be. So I'm going to call that res for resolution. I'm just going to set that to 4 initially. 4 times 16 is 64, so this should take up about half of the screen because Pico 8 has a 128 by 128 resolution. So 16 times 4 is 64, which should take, well, it should take up about a quarter of the screen actually. So we've got our global variables here. So in init, we want to set grid equals to new map, no, make map, and we'll use those columns and rows variables that we set up at the top. Then in draw, we want to draw this grid. So we're looping through columns and rows, and then we'll say grid. Actually, we'll just do a rect fill. This was the example I used earlier. So we want to make a rectangle for each one of these. Grids, and because we have 1 or 0 in the value here, we can actually just use that value. And the colors in Pico 8 are numbered from 0, which is no color, to 15 or 16, one or the other. So they've got 16 colors I can show you right here. These are the 16 colors that you can use. This just counts as blank. It's just black. And then all of these are other colors that we can use. So I'm just going to use 0 and 1 because it's easy. Switch back to the code editor here. Rect fill. So what we want to do is we want to go x for the x value multiplied by the resolution, y multiplied by the resolution, and then x plus the resolution, y plus the resolution. So that will set the top left corner is the x and y of the current cell multiplied by the resolution. So it'll take it down to the top left corner of the square. And then it draws that out from that to the bottom right corner of the square. And then we will use grid X, Y, and just put the value in there for the color. So let's see if this works. It's unclosed. I need to add this thing down here. Run. Okay, so that's interesting. One thing we want to do right away is before we draw this, we want to clear the screen so we don't see any of that text. So clear that. So the problem I'm having here is because my calculation in my draw function is slightly off. I actually want to add resolution after I multiply resolution. So top left corner, and then add the resolution from the top left corner to make the bottom right corner. So multiply the resolution and then run. Okay, so there's my grid. It takes up about a quarter of the screen, like I said. Quarter of the screen, and so we could also, if we make the resolution 8, it'll take up the full screen. Now we've got a problem here, which is because arrays because maps are 1-based in Pico 8, we're actually not drawing on the top left corner, which is what I want. We've got like a 1 tile wide gap around the edges of the screen. So I want to get rid of that. I'm just going to do that in a quick and dirty way by using the camera and just move it down and to the right by the resolution. And that should fix the problem. Yep, so now we've got it flush on the left side, flush on the top, and it just fills the screen, which is perfect. So that's just a random grid. Now we have to, now that we've got our data set up, so let's just take a quick summary of what we've done so far. We've got the makeMap function, which creates a map, which creates the data for a map, which goes all the way to the right and then creates data all the way down, and it just sets each of those tiles to a random value, which we don't really need. I don't really want it to do this right here, actually. So I'm actually going to cut that out, just put a 0 there. So now we won't see anything. And then, do I want to do this? Well, you know what? It doesn't really matter. I'll just set it to a random number. I don't like this because we're going to use this function again later, and we don't actually want it to generate random numbers for our new data set, but we'll get to that in a little bit. So makeMap creates this new map, random data, and then we do that in the init function, we create that grid, and then in the draw function, we just loop through that grid and we add a rectangle for every one of those cells. And we use the value that we created randomly, and we use the X and Y value for the actual location on the grid. So the next thing we need to do is we need to actually add the logic that makes it a cellular automata. So here's where that logic is. They've got the rules right here. Any live cell with fewer than 2 live neighbors dies. Any live cell with 2 or 3 live neighbors lives. Any live cell with more than 3 live neighbors dies. And any dead cell with exactly 3 live neighbors becomes a live cell, as if by reproduction. So the main thing we need to know to make this work is how many neighbors each cell has. And that's a little bit tricky. So we're going to create a new function up here after makeMap. Function count neighbors. And it's going to take our CMap, current map, and it's going to take an X and a Y. So what we want to do is we want to take the current cell. We need to check all of the cells around it, and then we need to add up a sum of whether those are active or not. So we'll create a local variable called sum, and we'll set it to 0. And then we need another loop. Now this loop, we don't need to loop through the whole data set. We only need to loop through the ones that are around it. So what I'm going to do is I'm going to create a loop with I, for I equals -1, and it goes through 1. And then another loop that has j equals -1, and it goes to 1. And All right, so what we're doing here, what we're going to do here is, and then sum will add, and we will add the CMAP x plus I and y plus j. All right, so we're adding all that up. So let me show you what we're doing here. So we've got the x and y for our current cell. Let's say our current cell is 10, 10. Say that's its coordinates. So we've got this function that loops through, and first it subtracts 1 from the x value. So it starts with 9, and it subtracts 1 from the y value. So it starts out with 9, 9. Then in the next cycle of this loop, the y value goes up to 0. So adding 0 to y makes it 9, 10. And then adding 1 to y makes it 9, 11. And then the x value goes up 1. So x value is adding 0. So we've got 10, 9. And then we've got the loop, which is 10, 10. And then it's 10, 11. And then we go back to 11, 9, 11, 10, and 11, 11. So it loops through all 9 of those cells. And it doesn't matter what these numbers are. But the problem with this is, what if we, right at the beginning, we won't have 10, 10. We will have 1, 1. And if we subtract 1 from that, we end up with 0, 0. And 0, 0 doesn't exist in our data set. So what we need to do, and what I think I want to do, so we could just cancel it out if the data doesn't exist. So if we do that, it's going to look like if I is less than 1. All right, so I'm going to create a couple more variables here. Local row equals x plus I, local column. Am I getting this backwards? Column is up and down. No, that's right. So y plus j. And then we'll use those here. Row, column. So let me show you what happens if I run this. We get an error because 0, 0 doesn't exist. So that's what I was saying, that, oh, actually it's erroring at that. But, oh. So I'm not calling this count neighbors. So an update is where we're going to want to call this. So so let's see if we can call this so we can see what the error that we're going to get is going to be. So we're going to need this loop again for the update function. Indent this properly. So we'll loop through all the columns and rows again. I do have this backwards, don't I? That's going to bug me. So columns, rows, it doesn't really matter, but I want it to be correct. Columns, rows, okay. Column, row. Column, row. All right. This is backwards too. Rows, columns. Let's see if it's still running. It's still running. All right. So the update function is where we're going to actually modify the data that we have. So the draw function displays it. The update function is what actually modifies it. And this is a pretty important distinction for a lot of game programming. You tend to have a draw loop and an update loop. And the draw loop runs right after the update loop. So you can update stuff before you actually, so you can change your data set before you actually draw it to the screen. So in update, we're going to want to change this data. So first of all, let's create a local variable called in and count neighbors. Grid x, y. All right, now we're calling that, and we've got an error. All right, so here's the error that we're getting. runtime error. So this is the error that I was talking about. It's not super clear, but what it doesn't like is that when this equals 0, there is no 0, 0 data in here. So we have to take care of that problem. So if we just make it ignore that, what would it look like? Actually, what I think I want to do, and what it looks like it's doing over here, no, it's actually not. It's just ignoring the edges. I'm not sure how it's working, but what I think I'm going to do is I'm going to just ignore the sides, in which case we could say if column is less than 1, then column equals 1. And if column is greater than columns, then column equals columns. And if row, I've got this, why do I have this backwards? Row, column. If row is less than 1, then row equals 1. If, I'm sure there are more elegant ways that we could do this, but I'm just trying to get it done right now. So row equals rows. I know there's a better way you could do this, but I'm going to see if it works. All right, so there's no error. It looks like it's working. So if it is working, then we will go back down here to the update. So it's calling in for every one of these rows. So now what we want to do is we want to start changing things. So when we have that number of neighbors, then we can go through these rules and actually set in the appropriate logic for this. So, but one thing, we don't want to just change the table on the fly, because if we change a cell, so if we change a cell in the middle, then the next cell is going to react differently, because this cell used to be filled in and now it's not filled in. So we want to always work off of the data set that we have and not change it until we've made it through this logic loop. So how we do that, and this is why I was talking about this random number earlier. I don't actually want that in here because I'm going to be reusing this make map function. Rows, columns. Do I have all this correct now? Row, column. Row, column. All right. Rows, columns. I don't know why I was doing that the whole video. So local new grid equals make map rows, columns, and I got it right that time. That's good. All right, so new grid equals a new map. And then in here, we want the number. We also want the current cell. Local cell equals grid X and Y. So we've got the cell value. So now we can run this logic. So any live cell, I'm going to call this alive. So if alive, actually I'm going to start with the negative value, dead cell with exactly 3. So if, make this a little narrower, make this little narrower. Okay, if not alive, and so if the cell is not alive and it has exactly 3 neighbors, n equals 3, then it becomes alive. So reproduction. So we take our new grid, we give it the X, we give it the Y, and we set that to alive for reproduction. So else if, so now we have any live cell, all 3 of these are live. This has 2 or 3 live neighbors. Fewer than 2 live neighbors dies. So if not alive and n equals 3, else if, oh, and actually no space there, else if alive and Yeah, alive, and we want to do 2 or 3 neighbors, so in. So this just lives on to the next generation. So this one doesn't change. Any live cell. So this one dies, and this one dies. So these are live that die. So fewer than 2 live neighbors. So in is less than 2, or any live cell with more than 3 live neighbors, or n is greater than 3, then new grid x y equals 0. So it dies. Over and under population, that's what this is. Over and under population. And then else, it doesn't change, right? That's the only other option. So else new grid x y equals grid x y. All right, so there's our logic. That's the actual nuts and bolts. This is the quote-unquote business logic of the application. Everything else is just handling data, but this is actually the nuts and bolts. So, and that's taken straight from the rules from Wikipedia. So, you know, I don't know how much trust you put in Wikipedia, but I would assume it's correct about this. So assuming Wikipedia is correct, here's the logic for our game of life. And we've got it ignoring the sides. Now, the last thing we want to do is once we're done with this loop, end loops, I'm just going to add that in for clarity. We're going to set grid to new grid. New grid. All right, cross your fingers. I feel like I've added too much code in here for this to work, but we'll see. Yep, just like that. So syntax error, expected near then, new grid, xy. So it doesn't like me assigning this new grid. So we're making the map, put the rows and columns in new grid. Why doesn't it like this? Alive grid, new grid, xy. Am I missing a parenthesis? If not alive and in, then am I missing it at the end of this line? Ah, I am missing one. Let's see if this works. No. Am I missing another one? If not alive and n equals 3, then so I'm not missing one there. Am I missing one up here? No. Alive grid. I don't know why it's complaining at me. I was missing one there. Then else if else. Am I using the if else properly? If not, then. So I guess I don't need parentheses. Let's try it without them. Oops. If alive. I do need them around this conditional though. So I'll leave those. All right. Attempt to compare nil with number. So n is nil. Why is n nil? Count neighbors grid and xy. So where's my count neighbors? I guess I've got an error in my count neighbors function. So sum is 0. I'm not returning sum. Okay, so that would cause us a problem. So end loops, now return sum. So I was doing all these calculations, but I wasn't actually returning the sum of those calculations. Let's run that again. Okay, so it's doing something. It's happening so fast I can't see if it's actually working. So let's bump down the resolution, give us a little more something to work with. Okay, so it's still just like ending right away. And this is clearly not the game of life that I'm searching for. So what is wrong with this? If not alive, so we're changing those things. Grid equals new grid. Why isn't this working? So I've got my business logic going. I suspect that the culprit is this logic here. So first of all, I'm going to change up the order here because it's annoying me. So let's do that. Do rows first. So now what I want to do, I think I'm going to just make it, even though that's not the way this is shown, I think I'm just going to make it wrap around so that things that come out this side will come out over here. So the way we do that is instead of just setting it to 1 here and kind of breaking, I mean, it kind of breaks the game of life. So if it's less than 1, instead I'm going to set it to the value of rows. So instead of just staying at the same value, it's actually going to take the value from the bottom of the screen. And we'll do the opposite here, where if it's greater than rows, do I need to do equal? Row equals 1, so it starts back at the top if it goes over the bottom. Same things here, columns, and then here we will equal 1. Let's see if that helps. So I still am not quite sure what's going on here. Let's make the resolution even smaller. Let's do just 2 pixels. 64, 64. Huh. So still definitely not the game of life. So what could be wrong here? So we've got, I don't think there's anything wrong with the make map function. This is pretty simple. I still don't really like that it's doing this, but I need that at the beginning. I'd like to do that like in the init function, so it only happens for the first map, but I don't think that's the culprit. So I and J, we're adding those together. We're doing this little calculation, then we're adding, what is CMap? CMap is the map that I provide. I don't actually, well, yeah, I do have to do that. So counting neighbors. So just as an experiment, this is not gonna work very well, but I'm just gonna do print. I'm going to print the sum of this just to make sure the sums look okay. And it's just gonna freeze for a second, and then, so yeah, those do look like the numbers that I would expect from this. 5, 4, 2, 1, yeah, all those. So it doesn't look like the neighbors function is the culprit. It looks like that's working just fine. So I suppose the next place to expect is this logic. So let's try something. If not alive, I wonder if this being just 1 or 0 is a problem. So let's make this into a conditional. Let's do grid equals 1. That would mean it is alive. Aha. Is this the game of life? It does not look like the game of life. So that's closer. It looks like that helped. So alive is getting checked correctly. Let's just check this logic again. So any dead cell with exactly 3 live neighbors becomes a live cell. So if not alive and neighbors equal 3, then this cell becomes alive. Else if it is alive and the neighbors are less than 2, fewer than 2 live neighbors, it dies. Or if it is alive and 2 or n is greater than 3, then it dies. Otherwise, it just keeps its current value. That looks right. I don't know why that's not working. Let's take a look at this again. It's definitely not the game of life. I mean, all these little like 2-line things shouldn't exist. They've got, I guess, so why would these be happening? So these little 2 lines, one of those cells has 1 neighbor. It has 1 neighbor. It is alive and it has 1 neighbor. So it should be dying. If alive and n is less than 2. I have a theory that it has something to do with this count neighbors function. Somewhere along the way, this is breaking. And I'm not sure exactly how. It could be because of the rows column thing, because I was struggling with that for so long. Wait a minute. X plus I. So this is doing the proper loop. If the row is less than 1, and it should be cycling that just fine. Oh, okay, so I know what's going on. So my mistake here is I'm not only adding all of the neighbor cells, I'm also adding the current cell. So this makes sense because a lot of these look like off by 1 errors, where they are just like 1 fewer pixel than I would expect from the game of life. So we're going to fix that just by subtracting from the sum the current x and y. And that looks more like the game of life. Let me try a slightly bigger resolution just to make sure, but I think we're in business. Am I? 64, that should actually be 2, shouldn't it? That's a little slow. Let's do 4. Ladies and gentlemen, the game of life. All right, change to this resolution. We'll try it. Ladies and gentlemen, the game of life. This looks correct. All of these look like patterns that I would expect. One thing that I am noticing is these weird little 3 lines. You see how there's that one in the middle that's just a 3? Now that should be oscillating. It should be going up and to the side. I don't know why that's not happening. But other than that, wow, that was a cool pattern. Did you see that? That was pretty cool. So other than that, I think we've got the game of life down. I'm going to post this code in the description if you want to see it, mess with it, whatever. And I think this might be a thing for Fridays. This might be just kind of a fun way for us to unwind at the end of the week doing a coding challenge like this. And Pico 8 just makes it really fun and easy. I'll also put a description for that down there if you want to check it out. So that's all for today, guys. I hope you enjoyed this little programming challenge with me. I hope you dig into Pico 8 and you find some cool things that you like doing with it. And we'll be back with another Pico 8 challenge next week. Thanks, guys. Give us a thumbs up if you like what we're doing here, and we'll see you next week. Remember, never stop learning. Bye.